So my name is Martin, and I want to talk about how we could tap data in CAD models. You know, we're small enough here. I'd be kind of curious just to hear what kind of CAD systems you have and maybe what you're looking to do before we start. I wasn't thinking about that, but maybe off to the right here, if you very quickly just comment.
We have engineers using primarily Sparks and no magic, and stuff is scattered everywhere. We're
Yep.
trying to figure out how to manage it.
Okay.
I don't have a CAD system, just intrigued by it.
Okay, sounds fair.
Same with me, I'm not super fan.
Oh, okay, great. Okay. Are you using CAD? Do you have CAD in your environment?
Yeah.
Oh, okay, great.
Also, Lisa Brooks employee.
Oh, okay.
Focusing on federal government customers, we've got a lot of this type
Yeah.
of application.
Okay.
We're seeing no magic.
Oh,
Autodesk,
yeah,
lots of
perfect.
Siemens products.
Yep, NX and so on.
I'm in search engine stuff, but I have a bunch of friends that are in engineering, so.
Yeah, okay,
This works employee really interested in the type of data generated from CAD.
okay, good. Good, well, this is the public service announcement. I think you all have that information available. So let me kind of provide a backgrounder in terms of a little bit about me, but kind of how this evolved. So this is one of those once upon a time in a land, digital land far, far away. I found myself in the world of data management, and in particular, engineering data management. And it was really motivated by a relationship we had with Autodesk, and it quickly became apparent that companies who had CAD drawings needed a way to manage it, right? And be able to really, at the end of the day, it was about finding it. Management was done through file folders typically. And so this picture, this is actually from an old client. And this was in the days of DOS, for those that might even remember that, right? I'm kind of dating myself. But look at the date on this down here at the bottom. This is 1990, and these folks, this is actually a screenshot, recent screenshot. These folks are still using this environment as a way to manage their CAD drawings, right? Which is kind of stunning when you think about it. But the interesting thing, and the reason I bring that up is because if you think about what's happened in structured data management is that we've applied this kind of library card mentality to being able to tie to drawings. And here's the tragedy. The tragedy in all this is if you look here to like classification and maybe a project name, you've got this rich document filled with a lot of design intent, manufacturing instructions, process instructions, maybe even purchasing information, and we're relegated to, in this particular case, really 3 fields. Right, it was kind of tragic, right? It's kind of like a library card that describes a book, and you've got the book with all this content, yet this library card has a handful of attributes that you look to find it. So it's clear that we've got, companies have got all this richness of data. How can we harvest it out? And so this is really a story about how we could take CAD content and then repurpose it, reuse it in a number of different ways. And so let me just cut to the chase. What does this potentially look like? This is just an example of how it might be presented. But what you see here in this illustration, kind of this example, is the idea that, okay, facets, we're all familiar with facets, but now what I could do is, if I have, some of you said you deal with CAD content in your organization, you have different formats, right? So this happens to be a file type weight, okay? That's kind of low-hanging fruit, maybe even related to projects, right? Oftentimes drawings have project information, or even the file folder has project information in it. Now, here's the interesting thing. We pick a particular item, a particular part, a particular assembly, whatever it has, and it's clear that there's a lot of other information that's connected to this. So in this particular diagram, this actually happens to be a screenshot from a customer. So this customer says, for this particular part, what I'd love to be able to have is things like model information, right? So some of this data actually comes from the drawing. This comes from within the drawing. But then there's other information like associated documents, specifications, contracts, whatever they might be. So I've got a document, a drawing, but that drawing is connected to other things. So this is one way that we can kind of virtually aggregate the information. So we're leveraging content for relationships. Another way to look at it is the bill of materials. So you've heard of bill of materials, right? The structure of information in a particular part. Or BOM, as we say. I don't like to use that word in the airport lines, but you know, there's BOMs in these drawings. And so this is literally information taken from within the drawing. I've got this data already defined. Let's take advantage of it. And then I might have the actual schematic or view of this information. Another way to look at it is, this is another illustration. This happens to be more AEC oriented, architect, engineering, construction. So anybody in the oil and gas space or type, oil and gas? Okay, who are you with?
Currently government contractor with Next.
Okay. So you're familiar with oil and gas. So this is a perfect example of being able to pick a particular part. I'm looking at a part. I find out it's a part of a refinery. So this is actual live data. And then that brings up a drawing, right? This happens to be a type of drawing that's similar to like an electronic schematic, except this happens to be a piping and instrumentation diagram, or a P&ID. But along this theme of repurposing CAD content, let's even take it a step further and say, well, you know, we've got Google Maps, we've got all these capabilities for graphical navigation. Let's inherently apply it to the drawing itself. So here I might, in this particular example, I'm highlighting a particular valve, right? So I've been able to get into the drawing, I've been able to recognize some characteristics about that drawing, and I connect to that item, I'm connecting to that item a profile characteristic. So here's this idea that I know I'm going to have relationships with this particular item, valve. I'm going to have relationships to other things. It could be so-called MRO, maintenance, repair, and operation information. It could be specification, it could be vendor information, etc. And then I can take that valve, that item, and then view it. And so this is an extension of the idea. This just is an animation, but it's the idea that now I've got a hold of the drawing. I can repurpose the drawing for the content, but let's take it a step further and repurpose it for the purposes of viewing. And I'm not illustrating it here, but literally you can go into this particular drawing and you can pick a part and then find things related to that part, right? So you'll have the in-drawing navigation. So at the end of the day, what this opportunity illustrates is the idea that I can find data based on the content, right? I've got all this richness of data. I've got design intent, I got purchasing, I got and so on. So I've got all this data in the drawing. Let's take advantage of it. And one of the things we can do is find it. We can also assess characteristics of that information, as you just saw. I can assign relationships to it, I can connect relationships to it, and then finally, let's not just stop there. Let's not stop at find and access, but let's continue the process and be able to view and interact with the view. Think of the drawing as graphical search navigation, right? Just like we have facets in that previous illustration, I can have facets. Well, take that thinking beyond just text and or facets for search, let's leverage the actual graphics. And if we're going to be able to actually leverage the graphics, let's do the viewing and do graphical navigation. So that's kind of in essence, what we're trying to do here is illustrate this idea of find, assess, and then view. So what are some of the common CAD platforms? Someone mentioned AutoCAD. AutoCAD, of course, is, I'm putting this up only just to get you familiar with maybe some of the names that might be in your industry or your organization, but AutoCAD, Inventor, and Revit. Those first three, by the way, are from Autodesk. So we listed these because these are kind of, AutoCAD is kind of ubiquitous in the AEC market, architect, engineering, construction market. Inventor is a 3D CAD tool. Revit is a BIM tool, building information tool used for design of buildings, etc. And then you have these other ones that you are familiar with. These are, the CATIA, Creo, and NX. These three are the big boy 3D modeling tools. So pretty sophisticated environment. So, and then you have some other ones that you may have run into or are familiar with. By the way, any other ones that you might be using or familiar with that I haven't listed that come to mind? These are pretty much the predominant CAD solutions in the market. So let's talk about a couple things. What's actually trapped in the CAD data? So this is specific information that's buried in the CAD drawing. So let's go through that a little bit. So one is, and this is really the key one, is in the world of CAD, the term drawing, by the way, tends to be an older term. The drawing tends to be something that was very popular, of course, several years ago, decades ago. Today, the term is more CAD models, just FYI. So CAD models is this idea of I'm going to be able to model it all. And the OID, the unique ID, is really critical to this because all drawings have a OID. And so if we can grab that OID, we now have the ability to link it to all this other information that you just saw us talk about. Of course, the name is obvious, the description is inside of this, the author is inside of this. Here's kind of the interesting thing, is this idea of a composed of, right? This is a term in the industry, in the engineering manufacturing space. So this particular drawing has parts, so it might be an assembly, a sub-assembly, but these parts are inherently included. So why not take advantage of that and have a bill of materials or composed of, right? So these are the embedded parts. If your customers are using AutoCAD in particular, then you would hear terms like blocks and symbols, etc. But the point is that this is information that's inside of the drawing. And then you have manufacturing processes that are inherently defined in the drawings, right? It's someone's taken time to put all this in the drawings. Let's tap it. And then finally, for quality-related applications, you have something referred to as geometric dimensioning and tolerances. And so if you're familiar with putting two things together, there's key tolerances, right? And it's plus or minus a thousandth of an inch or plus or minus 10 thousandths or whatever it happens to be. The point is that this is buried in the drawing. Here's the fun part. What can we derive from this? So we've got all this data. Now we could do kind of fun derivations, right? We can manage or manipulate this data. So what can we derive? We can derive the authoring application. So this becomes important. When I get a drawing, I want to be able to know, is that AutoCAD 14? Is that AutoCAD 2000? Which version of AutoCAD do I need to apply to that drawing? So for legacy, this is particularly important in terms of being able to recognize that. The second part is kind of a fun idea. Latest revision is obvious, right? So if you get into engineering manufacturing groups that have drawings, the key issue is, am I working to the latest version. PLM solutions, PDM, whatever, are all used in part to understand what's my latest approved version. Well, through techniques of search and what LucidWorks brings to the table, I can determine that. We could even determine the pedigree. Where did this thing come from? What were the branches? So we're working with the R&D studio. I start with something. I then go to the next revision. I then split that. I now have two derivations of a single version, and then so on. Kind of illustrated in this little diagram, right? I have splits. I want to know what the pedigree of that information is, because I may want to move back up the line. Of course, bill of materials we've talked about, and then we have the where used part. So in other words, a particular part is used by another assembly. You cannot do this, by the way, without some kind of data management tool, right? So product lifecycle management, maybe even SharePoint, you can do where used, but if you're not using a data management tool and all you have is file folders, you can look at a particular part and you would never know where did I use this part. So where used is a very common issue because of change management, right? If I make a change to this, where else am I going to impact in the stream? And then here's the other kind of interesting thing is we didn't illustrate it graphically, but think of this. I have a drawing and then I make changes to that drawing. In the oil and gas industry, if I send out a drawing to my consultants and I get that drawing back, what changes were in that drawing? Well, because I now have an opportunity to not only index the text, I can index the geometry. And we could show then the changes between this version and the next version or a subsequent version, maybe in line coloring difference, etc. But pretty an interesting application because we're now getting into that data. And then the ability to connect data with other sources. So this is just for FYI. So a common environment are these product data management or product lifecycle management. PDM, PLM are common ways that the CAD vendors use to manage their data. So Autodesk uses something called Vault, for example. And so Vault is referred to as a PDM solution. Of course, there's ERP, right? This is the Oracle, SAP, Microsoft Dynamics. There's content management systems like SharePoint or OpenText Content Server. And then MRO is maintenance, repair, and operations. Of course, this is the idea that downstream organizations have to manage what they put together, right? Facilities, refineries, whatever it happens to be. So you have MRO, and MRO captures all this data. So this is kind of a, what can we derive? So once we've got this data, what can we derive from it? That's pretty rich. I mean, you pause and think about all this data that's buried in these drawings. It's pretty rich. And instead of trying to connect a profile card to it, let's leverage search technology, really. I call search technologies kind of, for me, it's data lakes with BI on it. Another way to think of it, right? I've got all this data that I'm collecting, I put BI on it. In this case, happens to be Fusion. So how does it work? Let me kind of go through this because there is some assembly required to put this together, if you will. So how does it work? Well, first of all, you gotta have a mechanism to extract the content. So just as LucidWorks has libraries to extract data from Word documents, PowerPoints, Excel, you need the technology that allows you to open up, say, an AutoCAD file. So open it up without AutoCAD, by the way, right? I'm not gonna have the authoring tool. I could have the authoring tool. I was talking to someone earlier who is doing this, and they're literally doing a headless service of AutoCAD. They have AutoCAD running on a headless server, and they're just feeding drawings and then kicking out content and then indexing that content. So that I thought was an innovative approach, but that's clearly one of the things you have to do is extract the content. And here's kind of the key part of this is then being able to process that, pulling out the tag value combinations, right? So name, Martin, company, LucidWorks. So we need to be able to pull out tag value combinations. This is a little bit of an exercise, and it's peculiar to the CAD system that you use because terminology is not necessarily the same. And then we go into deriving the values, right? This is where probably the core part of, if you're looking to do this, this is the core part of what you would have to consider. So I will now want to derive a BOM, a bill of materials, right? I want to derive a structure. I want to derive relationships. So where used, attachments, things that are connected to this particular model, and then potentially enrich it from other sources. So in your organization, you may have a CAD drawing, but it's very typical that there might be a spreadsheet, Access database, maybe SharePoint, or whatever it has to be, where other data is already defined. So this is a great way, an opportunity, and the time to go ahead and enrich it from other sources. And then here's something interesting that you don't really think about, but normalization of, let's take units of measure. I'll just take normalization of units of measure. You say pounds, I say kilograms. You say feet, I say meters, right? Now you can extend this to all the units of measure, but you could also extend it into language. And so if you have a global organization and you have people retrieving content around the globe, how do you allow for folks to find that content in the language and the terms that they use, right? So if I'm in the world of electronic components, it becomes particularly important for that. And then finally, being able to create the thumbnail and the viewable. So you saw in that illustration that I started out with, you had a thumbnail, you had the viewable. 3D PDF is becoming a kind of a standard. There's other conventions that are available that are being used. So this is kind of the under the hood look. I mean, we can get into the details if you want, but that's, and then of course you submit all this to the indexer, right? And then magically all appears back in the UI and people can take advantage of all this data. So that's kind of in, you know, the backgrounder on all this. So really the net is how do we leverage the richness of all this data? And I think what's interesting is that the LucidWorks technologies that are now available allow us to really amplify that. You know what kind of reminds me of a little bit is like Uber. I think it was mentioned this morning, Will Hayes mentioned it, that Uber wouldn't be here today without, one, the internet, without online payment services, without mapping services, and so on, right? Boom, now we have Uber. Well, likewise, to do this, many years ago that we tried on several occasions with the other solutions I mentioned, much more challenging. We didn't have the technology we have today, but now we do have this idea of being able to leverage the richness of data to do, of course, the retrieval, derive the relationships, and so on. And then, you know, get into enriching the data structure, both the data structure for the drawing as well as the data structure for applications. Being able to get the specific and the derived data, and then finally being able to view and analyze and use graphical navigation to get around in your content. So that's the quick overview of really CAD connectors is, and doing this is really just a way to augment the reality of many businesses, right? You're already maybe using LucidWorks or Solar. You've got connectors maybe into other things. This is a connector story about how to take advantage of content in CAD models. So with that, I'm open to questions, comments.
You talk about the connectors that you have, which is kind of an add-on for Fusion, correct?
Correct.
So when I think of, oh, thank you. So when I think of connectors, I know I think of, attaching to a particular type of data source like SharePoint or OpenText or something like that, and then it knows how to communicate with that data source to bring the data in. So when you speak of connectors, what are you referring to? Because you're talking about various models and CAD drawings, but they could be stored all over the place. So how does your connector work in this context?
So, good question. How does the connector work? Let me go back to this illustration here. How does it work? The connector is actually the connector technology that I'm speaking of does all this. So it does the idea of extracting the content regardless of what CAD model it is. It does the tag value combinations. It creates the relationships. Now, if data is in open or a content server from OpenText or something to that effect, then at this point right here, process derived values, I can enrich this data from other sources, like content server, right? So if I know that here's a particular part that I've defined, and that part in content server might have specifications like the vendor or location or whatever it happens to be, then I can tie that to the model that I parse out and then present it as kind of a unified story, as we did in that first opening slide.
So I'm trying to think through this from. So from a pragmatic point of view, so I manage our Fusion server and I configure it in that. So I'm trying to think what am I installing? How am I working with your solution to make this actually work? Am I plugging something in? Is this a new parser? Because it's normally if I'm doing a new connector, I download the connector and I do the import into LucidWorks Fusion, and now I can actually make a connection to that data source. How would I work with your solution?
Yeah, so are you using the file system connector to do the crawling?
We could.
Yeah, so in the file system connectors, when I would decide that as I'm cron jobbing my crawler, I bump into something that looks like a drawing. Oh, it looks like a drawing, we're going to parse it this way.
You provide parser?
Yeah, yes.
Okay.
Yes, that's I'm not doing a commercial here, but the technology is such that, do I send it to a parser that looks at documents, open or PowerPoints or Word documents, or do I send it to a parser that treats CAD? We're the parser that treats CAD.
So then we would basically, import your solution into Fusion, and then that would be a callable parser that we can then refer to.
Yep.
Okay, that makes a lot more sense.
And then you would tell us, how do you want this data delivered, right? I don't know if you use JSON or other formats, but then before we shove it into the indexer and the pipes, then you could define, okay, here's how I like to have this information delivered, and then we could augment it with other information.
Perfect, that's helpful,
Yeah,
thank you.
so like this is a good example of data that is merged from other sources, right? So literally, this associated documents is just from file folders. This is from their ERP system that's done, and then the BOM is collected from the model. And so this is kind of a universal or a mashup, if you will, about that particular part. Hopefully that makes sense. Yeah, okay.
So are you collecting the data using the native CAD formats relationship model like XREF and AutoCAD, whatever Creo has, stuff like that? Or are you reading title block information, or how do you get that relationship?
Right, so we have, for every CAD format, we have the specific characteristics predefined. So if we know that we're running into XREFs or into blocks in AutoCAD, then we'll know, okay, that defines so-called the structure of that particular. If I'm in Creo and I see a part file, PRT, or I see a SLD from SolidWorks or something to that effect, then I'll know what that potentially means in terms of the tag value combinations that we parse out. So yes, it's unique to every CAD model.
Is it mainly for ones that aren't already managed in a PDM, that the PDM system would have that information?
It can, right? I mean, the PDM is going to potentially have just a handful of attributes, right? 3 or 4 attributes associated with that drawing. So we can merge that. That's a common technique, right? So we've got some data that's already defined in PDM or PLM, and then merge it with that record, so it appears as if it's part of the overall profile of that particular part or model.
Do you also try to parse the relationship between the objects on the drawing? If you go to your P&ID example, there are relationships there between these objects. The valve that you're showing is related to a pipe, and that pipe is related to this distillation column. Do you try to parse that and create
interesting. We could, theoretically. We haven't had that come up as a use case, but that's a good point. So this valve that I illustrated here, we could determine through the line relationship where it's connected. We haven't had that come up, but that's an interesting point. What we're doing here now is we're bringing a lot of intelligence to a P&ID, but that's an interesting use case.
Okay, thank you.
Any other questions, comments? Yes.
Thank you. Great presentation, by the way. So I'm really interested in all the kinds of use cases that this can provide, obviously with all the various industries that use AutoCAD, everything from security to part, in this case, it's very industrial, examples. But can you tell me a little bit about how these use cases have been used? Has it been used to determine like part recalls or tooling or some specific use cases with this data?
Yeah, so excellent question. What are the use cases for something like this? So the way I might couch it for starters is, why do organizations do PDM or PLM? They're doing PDM, PLM. The use case is kind of combination. It's being able to manage versions and releases, right? Because how do I determine across my file folders what is the latest release? So PDM, PLM has grown up to serve that issue. PDM, PLM, and other solutions like that have served the issue of relationships like composed of. What is this controller composed of? And then if I take a button, I might ask, where is this button used? Because I want to change the button, and I might impact 20 other devices, right? So without PDM, PLM, that's pretty impossible until now. So the proposition here is to suggest, okay, you might have structured data management, but here's kind of an organic way to take advantage of all this data that exists in these drawings. But yes, recalls, we work with automotive suppliers, and they have their scorecards, and they want to know what the issues are, and where else is this particular item used, and so on. The P&ID that I brought up here, the use case here is potentially emergency related. So an unnamed refinery in Southern California had an explosion 2-3 years ago, and they could not figure out what was in that unit because the drawings were manual and they were in the drawing room, and who's going to run in the drawing room and figure out where the stuff is? So that was kind of an interesting use case scenario. There's more, but anyway, I was just given I'm almost out of time notice. But I'm around. We're here at the show. We happen to be under the banner called CAD Nexion out on the floor. So if you have many more questions or comments, we'd be more than happy to field those. But thank you for your interest.